702.
The Naked Scientist.
Give us a call right now and ask your question from the wonderful world of science for Chris, and Chris will answer them. Good morning, Chris.
Hey, morning, UB. How you doing?
Lekker. We've got an interesting story. Transplanted cells that can repair wounds, egos, or
That's
physical
right.
wounds.
I'm not sure if it works on politicians yet, but I'm sure they're working on it. But this is a story which has come out of the University of Bristol, where scientists are eager to try to improve the rates at which wounds or injured tissues can heal themselves by grafting in cells. We've come through this era of medicine where we give drugs, molecules that can help things to get better. But there are some diseases where physically tissues have been injured or damaged or destroyed, or cells are broken down, and we need to put cells in to replace them and repair the tissue. The problem at the moment is that when we put cells from, say, one part of the body, say a stem cell, into an injured body part, the place we're trying to put the cells is not very receptive to those cells going in. It doesn't really encourage the cells to integrate and survive. So what Adam Perryman and his colleagues are actually publishing in Nature Communications this week is a way of making the cells make their own success story when they go into a new site in the body. So what they do is they take some stem cells and they mix them in a solution of a kind of special detergent with a molecule which you find naturally in the body at wound sites called thrombin. Now, this normally clots blood, and blood clots are very important because they stitch wounds together and they provide a framework for the repair of the tissue. So what they're effectively doing is endowing these stem cells with an enhanced ability to repair tissue locally. So you end up with these cells that have got these thrombin molecules sticking all over them, a bit like a spiky meatball. They then put those into the wound site, and the thrombin enzyme grabs another molecule which is naturally there in the blood called fibrinogen, and it breaks it down into a sticky meshwork called fibrin. And this stitches the wound together by making a structure called a hydrogel. And this is really fertile ground for these new cells coming in to stick down into, to integrate into, and be supported while they then survive, proliferate, and also encourage blood vessels to grow in. Now, they've done some initial experiments on fish because they're using zebrafish, which are really easy models to study. It seems to work incredibly well. Now, it's early days, but the fact that they're able to do this and endow these cells with these enhanced healing capacities suggests that we're moving now towards an era where we'll be able to take some stem cells from an individual and then go into an injured part of the body. It might be, for instance, a joint with arthritis and we want to regrow cartilage in that particular joint. It might be a breach in the skin where you've had an operation or you've had an accident and you want to make the tissue repair itself faster. You put the stem cells in, and using this enhanced ability to integrate and stitch the wound together and lay down fresh tissue will get much faster and probably superior rates of wound and quality of wound healing. And all those things mean a better outcome for the patient.
Bruce, good morning.
Good morning, Eusebius. The question that I have for Chris is based on an answer that he gave on the 5th. He said that one of the ways to prove that the Earth is a ball is that when the ships go further away, when you're at the beach, it disappears from bottom up. And then how is it that when I have a camera or binoculars or a telescope, I'm able to zoom it back to view? And some astronauts say that when you're on the moon, you can see stars. Some, they say you can't see stars. So how is it that the Earth is a ball and people have been to the moon when we have those kind of discrepancies?
This goes back to this whole idea of, is the Earth round or not? And the evidence we have is that the Earth is a ball in space. And we have evidence which is collected from people observing on the Earth's surface. And the point I was making is that because the Earth is a ball, if you stand on the beach and you watch a ship sail away from you, a ship will disappear over the horizon. And as it disappears over the horizon, you can't see the bottom of the ship, just the mast. And then you see the top of the mast, and eventually you the flag, and then nothing. Now, that can be explained only on the basis of a ship going over the curvature of the Earth. When we put something into orbit around the Earth, like a satellite, we can take pictures of the Earth from space, so we can see that the Earth is a ball. When we stand on the moon, because as Bruce says, There are astronauts who've been on the moon, they'll look towards the Earth. They can see that the Earth is a ball in space. And when we visit other planets, we've sent probes, for instance, to Mars. We've sent probes to Saturn. We've had probes like New Horizons, which went past Pluto. We can see that these objects are spherical or spheroids. They're not always perfect balls. They're often slightly deformed and distorted for various reasons, but they are a ball shape in space. The Earth is no different, and I'm not really clear what the point about the stars being visible from the moon is. The point is the moon is another body in space, and in the same way that we can see the stars in the sky above the Earth, if you're out there on the moon, you're going to see the same stars, or many of them, that we can see from the surface of the Earth. So you'd expect that.
Elvis, good morning.
Good morning. I'd just like to know, I'm a cancer patient, and I've actually got colorectal cancer, and I use cannabis suppositories, which is high THC, and I put it up my rectum because the cancer is right on my rectum. And I'd like to know, is there any sort of truth to the fact that cannabis actually has some sort of a healing effect?
This is a very difficult area because when we talk about cannabis, we're not talking about one chemical. If you go into a drug trial, the pharmaceutical companies will have usually made a molecule. It'll be a pure chemical, and they'll give a certain dose of it at a certain rate in a certain way, and they'll measure the outcome, and they'll compare that administration with a placebo, either in the same person, because you give the person the drug and then you give them a placebo and you compare the difference, or you compare two similar groups of patients and neither knows what they're getting. You give one a placebo, one the real drug, and you find out what the outcome is. The problem with cannabis, in inverted commas, is that this is the cannabis plant makes a complex mixture of molecules, all at different concentrations, and people are giving these things at different doses to themselves or administering them in different ways at different rates. And so you've got different people taking different things in different ways for different diseases. And then, not surprisingly, some people say, hey, this worked wonderfully. And other people for whom it didn't work don't say anything. And the people who are dead, of course, because it didn't work for them at all or killed them, they're not going to say anything, are they? So you might end up hearing the message you want to hear rather than it being subject to proper clinical scrutiny. So it's very important not just to see something on the internet and go, oh, I've heard good things about that, I'll go and try that. It's very important to make sure that the evidence that we have is correctly collected and it's done in a proper clinically approved way that is a placebo-controlled trial or equivalent, because otherwise you can be very severely misled. And in situations that are life-threatening, it really is important that we do this properly. It's certainly true that there are chemicals in cannabis that may well have effects on certain diseases. And many of these chemicals are active because there are receptors for some of these chemicals in many tissues around the body, suggesting that those tissues may have the ability to respond to these chemicals. How they respond and whether they respond positively, that's a very different question. One useful use of cannabis-like chemicals that I have come across in the context of diseases like cancer is that cannabis tends to, reduce nausea and vomiting. And if people are ill with cancer or they're taking chemotherapy, one of the problems can be that people suffer dramatic amounts of weight loss and low quality of life because they feel sick and not well. And if you can reduce those sickness symptoms, especially during chemotherapy, then that can make people feel much better straight away. So there's one positive. The other point is that it also encourages appetite. And one of the problems with cancer is that people often don't want to eat. They develop this condition called cachexia. And cachexia leads to dramatic weight loss, which is not good either. And so if you boost appetite, it can also help people to maintain a more healthy body weight. So there's a range of potential positives, but one must be very careful not to conflate hearsay and people's outlandish claims because they want to sell you something with what's properly obtained clinical data.
Chris, there's a question on the SMS line here, and a couple of people have asked the same question on Twitter, I've noticed, following on from your science story at the beginning of this segment. Morning, Eusebius and Dr. Chris. The wound repair that Dr. Chris mentioned at the beginning of the show, does it also help to prevent keloids or keloids? I've never heard of that term before. Explain that for us, and what is the answer, Chris?
Well, a keloid, and this is the reason this person's probably asking this, tends to be a much more common phenomenon in people with black skin. You'll have seen this probably. If a person has, say, a skin lesion removed or gets a skin lesion, then you might see an overgrowth or a thickening of the skin, like a very visible scar in that area. Yes. And it would appear that for some reason in particularly black skin, but anyone can get this happen, but it's more common in people with black skin, you will get an overgrowth, like the repair process that fixes the skin goes into overdrive, and you get an excess of the fibrous thick tissue that heals up the wound very effectively. Now, that needs the attention, if you want to deal with it again, of a plastic surgeon who can help to reduce that keloid. And also there are various things that can be applied at the time of surgery to reduce the risk of a keloid scar occurring. Now, the story I covered by Adam Perryman is a very preliminary story, and the idea of this is to really lay the foundations of how we're going to do cell-type repairs in the future. They're not at the stage where they're going to start putting cells into people anytime soon, because they're just doing this in experimental fish at the moment to show that, establish effectively the parameters of how this is going to work. But in the future, we're going to get a lot better at doing this sort of tissue engineering. And certainly, things like keloid scarring and making scars heal up more cleanly with a lower risk of infection and more quickly is definitely going to be one of those things. And maybe in future, when you go to the doctor and you have a cut or an injury, or you go and have an operation, part of the treatment won't just be preventing infection by giving antibiotics. It will be injecting into the wound some of your own stem cells and some other factors to make those stem cells help to knit the wound together much faster, for example. I think those days are not far off.
Raquel, good morning. Thanks for calling in.
Morning, CBS, and to all your listeners. Thank you for taking my call. I want to ask the naked scientist basically is, in the Indian Ocean, we're experiencing a lot of cyclones, and I want to know basically what is the reason for all of this activity.
Yeah.
Hello, Raquel.
Thanks for that question.
Well, the answer is that these are tropical storms, and tropical storms are caused by warm air and pressure differences and the air trying to move around. So if you have warm water in the ocean, the warm water warms the air above the ocean, but also the water evaporates, so you end up with very warm, very moist air. And this is very low in density, so it rises very fast. And as it's rising very fast, it expands and cools, so the water then condenses and it releases more energy, which makes the air rise even faster. And if you've got warm air rising away from a patch of the ocean surface, something's got to come in underneath to replace it. And that means you bring in colder air from across the planet's surface. And because the planet is enormous and it's spinning, the air which is going round with the planet is turning in a very big circle. So if you bring in air from a big area across the Earth's surface, that air is turning in a big circle. And if you bring it into a small area, you're making something that was turning relatively slowly in a big circle now turn in a very small circle. And because of a phenomenon called conservation of angular momentum, the air can't not turn, but because it's got far to travel, it speeds up. So you end up with it being far windier. And this is why hurricanes and cyclones, A, feed on and form over water, and B, why they're turning. And so when you get high ocean temperatures and patches of warm water over a patch of the ocean surface, you will much more likely spawn a storm over that patch of the ocean surface because of the warm rising air saturated with moisture from the evaporating ocean.
Hamilton, good morning.
Morning.
Yes, sir.
I have a question here. This bothers me every day. When I'm sleeping on a bed or so, maybe somewhere, I can hear sound that comes from far away than when I'm seated or standing. What causes that?
Hamilton, is your head against the pillow when you're sleeping?
Yes.
Yeah, I'm wondering, are the sounds that you're hearing actually the sounds coming from within your own body? Because one of the things that happens when we go to sleep and lay our head against a pillow is that you get this thing called the occlusion effect, and you actually close off the cavity of your ear because the external ear canal that you can stick your finger in is now not in connection with the room air, but it's a closed cavity between your ear and the pillow, in other words, your eardrum and the pillow, and that closed cavity can cause resonance. So any sound vibrations that go in there, certain frequencies are going to amplify. This is the same reason when you hold a seashell up to your ear, people say they can hear the sounds of the sea. It's called a Helmholtz resonator, and it's because the shape of the seashell tends to amplify certain frequencies more than others because it's a resonant cavity. So I suspect that when you're laying down with your head on the pillow, on the couch or in bed, you're creating your own Helmholtz resonator in your ear, and this is amplifying certain frequencies from the environment that are naturally there, and you're tending to hear those sounds and interpret them as things coming from a long way away.
Hamilton, are you sure it's not the missus whispering in your ear?
No, it's nothing.
Thanks for the question. Herman or Herman, good morning.
Hi, UCBS. Big fan. Hello, Chris.
Hiya.
Thanks for calling in today. What question have you got for us?
I'm an amateur astronomer and have a few telescopes and look at the skies often. And I've wondered if the whole galaxy system, the Milky Way, is in motion and all the other galaxies are in motion. Why do the stars that we see stay so static from our observation point? So Orion hasn't changed over the last 200 years, but the stars are moving and our galaxy is spinning around. How does that work? Why do they stay static from our view on Earth?
Hello, Herman. You're quite right. We live in the Milky Way. The Milky Way is a spiral galaxy, and we're on the outer edge of one of the arms. And when we look across at the Milky Way, what we're looking at, because it's a flat disk of a couple of 100 billion stars in there, you're seeing a couple of 100 billion stars inside profile. Now, they are all turning. The whole thing is turning. And over millions of years, the stars in our Milky Way galaxy will complete an orbit of the galaxy in the same way that the Earth completes an annual orbit of our star, the Sun. Now, the distances are absolutely enormous. And as a result, the distances that we see changing is tiny for us. But if you were to look over a really long period of time, millions of years, you would see this happening. You'd also see one other interesting phenomenon where the stars aren't flat and staying flat on the plane. They're also bobbing up and down a bit. And so you can also describe the stars not just going around in a big circle, but also going up and down in that big circle. So it's like the horses on a merry-go-round going around in a giant circle.
Thank you, Herman. Eric, very quickly, what is your question? Let's squeeze it in.
Hello there. I was just wondering if there's been any advance on stem cells for macular degeneration.
Good morning, Eric. The answer is that people are looking very aggressively at this because macular degeneration is a massive problem. Just to clear up what that is, in the back of the eye is the retina. The retina does the job of turning the light that comes into your eye into signals that are sent to the brain so we can see. The macula is the most sensitive part of the retina, where when you're reading a book or looking at someone's face or watching television, that's the part of the retina that you're using. And for a range of reasons, as we get older, you can lose the health of that part of the retina. You begin to lose the cells that are there, the photoreceptors, the rods and cones, for example. They begin to break down, and if you lose those cells, you can't then send signals into the brain, so you end up with a blind spot on your vision. Researchers are looking at this fairly aggressively with ways to restore the health of that patch of the retina, and they are now doing experiments where they can put stem cells into the retina, and those stem cells wire themselves in and turn back into new rods and cones, and they can restore vision. And there are some experiments, they're quite preliminary, in animals, and there are also some experiments doing a similar thing with gene therapy to improve the health of the retina, to preserve sight in humans now as well. So it's very, very important not to get this wrong because of what's at stake. So the progress is relatively slow, but it's certainly promising.
Thanks, Chris. Have a beautiful weekend.
And you have a lovely weekend, everyone. Thanks for the fantastic questions. See you soon. Bye-bye.